Today, I'm going to introduce you to collections. The first question we have to ask ourselves is, what are collections? So we have our fancy definitions. A collection in Java is an object that groups multiple elements together into a single unit so that they can be stored, accessed, and manipulated together. The software engineering definition is the Java Collections Framework provides interfaces and classes that represent groups of objects and supply standard operations such as adding, removing, searching, iterating, and sorting. So essentially, in plain English, a collection is a container that manages multiple objects. That's all a collection is. It's a bunch of objects. But let's dive into the collections framework. So there is a hierarchy in collection. So at the top is collection, which inherits from iterable. Collection is an interface. Three interfaces implement collection or extend off collection. There's the list interface, the queue interface, and the set interface. The list interface, these are ordered collections. They're index-based collections. So you access collections based on index. You access an element in the collection based on index. Lists allow duplicates. Sets, on the other hand, every element is unique. No duplicates are allowed. Queues are known for their first in, first out order. So they're inserted first and they're released first. Think about it as a line in a movie. The person who's first in line goes in and leaves. Think about it like that. Map, on the other hand, is not a collection. It stores key value pairs, okay? So under list, we have three main types: array list, linked list, and vector. Array list is the most commonly used. Linked list is also used. Vector is a legacy type of collection. From queue, we have linked list and we have priority queue. Those are the two that are used. Linked list is unique because it implements both the list and the queue interface indirectly through the deck interface. Set, we have hash set, which is the most commonly used set, followed by tree set and linked hash set. I'll talk more about these in detail in upcoming lectures. So there's a concept of ordered versus sorted. So ordered pertains to insertion order. Think array list, linked hash set, linked hash map. And then we have sorted. So they're arranged based on a natural sorting order. So collections like tree set, tree map, and priority queue. Again, I will talk about these later in more detail. Let's go back to our hierarchy and notice that everything in green is a concrete class. Everything in pink is an interface. Feel free to pause this presentation at any time to take a closer look. Now, collection, because of the collection interface, there are common collection methods that are common to all concrete implementations of collections. I'm not going to go through them in detail here because we will go through them in detail more when we talk about the individual collections. But of course, we're going to be adding, removing, clearing. We're also going to check if collections contain a certain element, is empty, etc. We also have other collection methods, such as for each. That's a fairly common one. And these others, which again, you can pause the presentation and take a look. And here is a table comparing the various collections and maps. I'm not going to go into this in any detail at all because I will cover these collections individually. So here's the takeaway. In list, order matters. So lists are ordered collections. They're ordered based on insertion order. Set, they're not ordered, but each element is unique. Queue, processing order matters. The processing order is first in, first out. And map, you look them up by key value pairs. We're done.